You won't believe it, but now it's certain the Webb telescope has once again discovered some of the oldest galaxies in the universe. Scientists from the JADES project have now discovered 5 galaxies that should provide us with more answers to the pressing questions of cosmology. Does dark matter really exist, and is it one of the basic building blocks of our universe, or have we made a crucial mistake here? 5 galaxies with Z values of 11 to 14 show us that we have overlooked something important in the universe. Scientists from the JADES program have now achieved another stroke of genius. As part of the James Webb Advanced Deep Extragalactic Survey, or JADES survey for short, the earliest and most distant galaxies in the universe have been identified and studied. Thanks to JADES, we will be able to understand the conditions in the early universe and reconstruct the processes of galaxy formation shortly after the Big Bang. This knowledge is essential if we are to decipher the true nature of our universe and thus uncover the secrets of creation. The main objectives of the JADES program are in-depth studies of galaxies that formed only a few 100 million years after the Big Bang. These galaxies show us the early phases of cosmic development. If the cosmos really was young back then when the new telescope was launched, scientists still assumed that our universe began with a Big Bang 13.8 billion years ago. You can imagine how eagerly the researchers waited for the first images from the new telescope. It was clear that the James Webb telescope, with a range of more than 13.5 billion light-years, would provide the first images of the time just after the Big Bang. Experts expected to see images of the first young and still rather shapeless galaxies and to identify stars of the first population within these galaxies. These first stars are said to have been true giants with an indescribable luminosity and a very short lifespan. It is now apparent that neither these bulky first star clusters nor the giant stars existed, at least not in the epoch that we can now illuminate for the first time with the JWST. It's possible that the first stars and galaxies were formed in a completely different way than we previously assumed and that the universe is far older. The images from the JADES program are overwhelming and are now giving us our first impressions of what the universe was really like 13.5 billion years ago and more. First, spectral analyses of reionization. It may sound strange, but it's true that the day the cosmos became light really existed. Imagine the universe as a dark cloudy soup and suddenly something changes in the cosmic structure. A new chemical physical process has started and suddenly neutral hydrogen is transformed into ionized hydrogen. The analysis of this reionization phase, in which the first stars and galaxies transformed the universe from an opaque to a transparent state, is of great importance. By analyzing in detail the chemical composition and star formation activities of the discovered galaxies, we can now get closer to these evolutionary processes. We need to find out what really happened back then, and the JWST is the key tool here. Leading institutions and scientists from various countries have come together in the JADES program. Participants include the European Space Agency, ESA, NASA, and the Canadian Space Agency, CSA, which are also the main initiators of the telescope. The program focuses on the ultra-deep field, a small region of the sky that has already been studied by the Hubble Space Telescope and contains almost 100,000 galaxies. JADES GS Z14D0, one of the oldest known galaxies. The galaxy JADES GS Z14D0 is one of the most remarkable discoveries of the James Webb Space Telescope and is currently considered the most distant known galaxy, with a redshift of 14.32. It existed only about 300 million years after the Big Bang, making the existence of this galaxy actually impossible based on our current cosmology. If we consider that billions of years of evolution are necessary to form galaxies like this one, the time of formation of the galaxy must have been before the Big Bang. The ability of the JWST to observe such distant galaxies allows us to see for the first time what the universe was really like back then. The observations of JADES GS Z14 show that even in this early phase of cosmic history, highly complex structures were already present that contradict the previous picture of the early universe. This discovery supports the theory that galaxy formation and star formation could have taken place faster and earlier than previously assumed. But if this is the case, fundamental assumptions of our physics are not correct. JADES GS Z14D1, Gateway to Dark Energy. With the galaxy JADES GS Z14D1, we have another candidate that actually falls under the category of impossible, but this galaxy is undoubtedly a reality. It is located at a similar distance to Jade's GS, Z14d0, and with a comparable redshift. It also existed around 300 million years after the Big Bang, making it one of the earliest known galaxies. Detailed spectral analyses of this galaxy reveal its chemical composition, and thanks to the ingenious instruments of the JWST, we are witnessing for the first time star formation activities that may have taken place at the very beginning of the universe. Webb spectrometer data show us what was happening in space 13.7 billion years ago with an accuracy astronomers could only dream of. The powerful instruments prove that even in this early phase of cosmic history, an abundant new formation of stars took place. Again, the data collected from this galaxy is so unusual that it is adding fuel to the current debate in cosmology. The discovery of such distant yet large and bright galaxies challenges previous models of galaxy evolution. We simply have entities here that are too large and too evolved to be witnesses of reionization. These actually incredible discoveries could provide important clues that dark matter and dark energy may play an even more complex role in the evolution of space, or they may lead us to a whole new force of nature and dimensions of physics that were previously unrecognized. In particular, the role of dark energy, which is thought to be responsible for the accelerated expansion of the universe, is presented in a whole new light by the current observation of the JWST. Thanks to these findings, we may soon be able to decipher the true nature of this mysterious force and thus also understand the blueprint of the cosmos. Jade's GS, Z13d0, Lyman Break Galaxy at the edge of the universe. The galaxy Jade's GS, Z13d0, is a shining example of a Lyman Break galaxy. With the redshift of 13, this galaxy existed only a few hundred million years after the Big Bang. Lyman Break galaxies show a characteristic absorption in the ultraviolet spectrum. This type of galaxy once again plays a special role in the assessment of the early universe. These types of galaxies are usually found at redshifts of 2 to 7, but not at Z13 or Z11. This type of galaxy produces many new stars and the entire formation is very active, making them particularly luminous in the ultraviolet spectrum. Lyman Break galaxies show strong absorption at wavelengths below 912 angstroms in the ultraviolet spectrum. They get their name from this limit. Scientists refer to the threshold of 912 angstroms as the Lyman break. The high light in the UV range is absorbed by interstellar hydrogen. These are optimal conditions for the Webb telescope, and the precise investigation of star formation and chemical composition in these galaxies is practically child's play for the JWST. The high absorption is an indication of enormously intensive star formation within these galaxies. Jade's GS, Z12, did the reionization not exist? Actually, the high star formation rates in these Jade's galaxies speak for processes that actually show us a young universe. High star formation rates are consistent with galaxies that are just beginning to develop. What does not fit are the complex shapes of the galaxies and other characteristics such as their size and density. All this speaks against us seeing witnesses of reionization with these galaxies. Jade's GS, Z12 could be further evidence that this phase of the universe may not have existed. We must assume that the first stars and complete galaxies formed much earlier than previously assumed. Jade's GS, Z12 also existed only a few hundred million years after the Big Bang. Once again, the JWST has demonstrated its unusual capabilities by taking a close look at the chemical composition and star formation activities of this galaxy. The first data show that the stars within Jade's GS, Z12 are being born unusually quickly and in large numbers. This would suggest an early mass development of stars, which scientists also refer to as a starburst. Until now, however, researchers did not assume that the first stars were formed in large numbers within large galaxies. Rather, they drew a picture of the first star-forming regions after the age of reionization. This calls our previous models of cosmological development into question. Once we have understood how the distribution of dark matter in the early universe really was, we can also draw conclusions about dark matter as a framework for the formation of galaxies. Dark matter is considered to be the secret building block that influences the shape and dynamics of a galaxy. We do not yet know to what extent the dark parts of matter and energy are involved in the formation of visible matter. Researchers are trying to unravel this mystery in facilities such as the Large Hadron Collider in Geneva. But believe it or not, so far not even the best particle physicists in the world have succeeded in detecting dark matter. JADES GS Z11, on the trail of dark matter. With a redshift of Z11, the galaxy JADES GS Z11 is somewhat younger than its colleagues, but it's no less interesting. Despite the small difference in age, this galaxy also existed at a time when the universe was only a few 100 million years old. We must realize that these galaxies are just a few examples that have been clearly identified and documented so far. Despite the accuracy of Webb's analyses, it is a long way from the sighting of a fuzzy point of light in the cosmos to a complete analysis of the spectra of light that has been traveling to us for more than 13.5 billion years. In plain language, this means that there are hundreds, if not thousands, of other galaxies with Z values between 11 and 14 in Webb's deep field images. Webb has taken 2 deep field images in his short period of service so far. Both already show an impressive number of distant galaxies, and the number is growing all the time. The existence of these distant and complex galaxies suggests that we have misunderstood the distribution of matter in the universe. So our entire picture of the universe may be flawed. Dark matter is supposed to provide us with the necessary gravitational framework that attracts matter and holds it together, thus enabling the formation of galaxies. But what if this matter does not exist? Then we have to start our physics all over again. Click subscribe now and be part of every new video.